All right, ladies and gentlemen, today we are going to take a look at ratios. Our objective is that every student in the class will be able to write a ratio in three different forms and to use a model to represent ratios. Now, this is standard 6.1.6 using models to represent ratios. So let's go ahead and move on. First thing we have to ask ourselves is what is a ratio? A ratio is a comparison of one thing to another by division. But to better understand ratios, we just want to take a closer look at a good example that we have here. It says, what is the ratio of circles to triangles in the green square? So if we could count the number of circles in the green square, we can see that there are one, two, three circles, and the number of triangles is one, two, three, four. So the ratio would be 3 to 4. Now, a ratio can actually be written in a couple different ways, or three different ways. We could also write this as 3 to 4, or we could write it where it looks like a fraction as 3 to 4. Now, if you noticed, each time that I wrote one of these ratios, I said 3 to 4. Even on the very last example, many of you may have thought that I was going to say 3/4, but a ratio is a comparison of one thing to another, so we have to say 3 to 4. Now, I could also compare the amount of circles to the total amount of shapes. That is comparing part to a whole. If I were to do this ratio, again, the amount of circles to the total shapes, I have 3 circles, and the total number of shapes inside the green square would be 7. So I could write it as 3 to 7, 3 to 7, or word form 3 to 7. So those are three different ways to write a ratio. The next thing that I want to take a look at is if I add a couple more triangles to our green square, we now have a new ratio. And the ratio of circles to triangles would now become 3 to 6. Let me write that in yellow again so you can see it a little better. 3 to 6. That's circles to triangles. And if we wrote it again in word form, it would be 3 to 6. And if we wrote it to where it looks like a fraction, it would be 3 to 6. Now, many of you are probably realizing already that 3 to 6 as a fraction can be simplified. Divide the numerator and the denominator by 3, can be simplified into 1/2. Now, with a ratio, we don't call this the numerator and we don't call this the denominator. It's just a term that represents something else. So we're not going to divide the numerator, but we're going to divide one term and the other term by the same number in order to simplify a ratio. This is called an equivalent ratio. So what we're trying to do is actually point out that, and I'll use green to say that for every one circle in the picture, we have 2 triangles. So if I group them together, you can see that one circle would go with 2 triangles. One circle would go with 2 triangles. And again, one circle would go with 2 triangles. So 3 to 6 would be equivalent to the ratio of 1 to 2. Let's move on and look at the next page. Here we have a problem. It says if there are 27 pencils, you can see the red pencil and the yellow pencil. If we have 27 pencils, represent a ratio of 4 to 5 for red pencils to tan or yellow pencils. tannish yellow. All right, this means that we're going to have 4 red pencils because we see the number 4 comes first and red comes first in the ratio, and we're going to have then 5 yellow pencils. So first I'm going to drag out my 4 red pencils. 1, 2, 3, 4. Now I need 5 of the yellow pencils. So 1, 2, 3, 4, 5. Now am I finished? Of course not. Right now I only have a total of 9 pencils, and I need a total of 27 pencils. So what am I going to have to do? I'm going to have to increase the number of red pencils and yellow pencils, but I want to keep my ratio the same of 4 red for every 5 yellow. So I'm going to add 4 more red. 1, 2, 3, 4, and 5 more yellow. 1, 2, 3, 4, 5. Again, I count the total number of pencils, and I'm still only at 18, so I'll have to add 4 more red ones and 5 more yellow ones. 5. Now if I count my total number of pencils, I actually have 15 yellow pencils and 12 red pencils, and together that would equal 27. So our ratio of 12 to 15, 12 red to 15 yellow, should simplify to 4 to 5. And if I look, they're both divisible by 3, both terms. And if I divide 15 by 3, I get 5. 12 by 3, I get 4. Now, where would a ratio come in handy in the real world? Well, if we look at the next picture, sometimes in science, a scientist may shock up a certain area of a river or a lake to determine a population of a smaller area, and they can look at ratios or use the ratio of fish in that area to determine the total population. So if we acted like they had shocked up this particular area, maybe it's a 10-foot by 10-foot area, and the pond is actually 6 times that size, we could see there are 1, 2, 3, 4, 5, 6, 7, 8 bass for every 2 catfish, and that's in that 10 by 10 foot square area. So they could use a ratio, a conservationist, to determine maybe the population of bass across an entire lake or in an entire river, in which if they know there's that many bass in a smaller area, they could multiply it and set up a proportion to determine the population of different species in a larger area. So it becomes very important to learn how to use a ratio, as well as simplifying or finding equivalent ratios, and of course writing a ratio in 3 different forms. I hope this helped you out with understanding ratios. Have a good day.